Good afternoon, guys. So, welcome to Domain Analytics. So, which is sponsored by 360DigiTMG. So, as we know, in the first day, we have seen automative analytics and what are our agendas and what we're going to work on, right? So, in the last previous session, we're going to do a quick recap. So, in case if you have missed my session of day one, I suggest you to watch the session. Okay. So, automative analytics, guys. So, what is meant by automative analytics? We have seen that. So, what is automative analytics and what are our agendas, right? What is the introductions of that? So, what is this automative analytics? So, guys, automative analytics is the automatically detect relevant anomalies, right? So it's nothing but an automatical thing which is going to detect relevant anomalies. So, okay, like patterns, and we're going to deliver insights of business. We're going to see what are the analysis of IT invention that are required, right? So this emerging technologies such as artificial intelligence, energy, machine learning algorithms. It's all continuously matters on operational performance, guys. Okay, why we are gonna implement this data science fields or data science things or data analytics? Why we are gonna apply on automative analytics? All right. So what is the reason? So guys, in here in domain, we are gonna show you how we are gonna implement the topics, how we are gonna implement the concepts like KNN, K means automative analytics, and what is the result we are going to get. So that is the one main thing we are going to see, guys. Okay, well, how this automative analytics is used in data science fields, how it is important to us, how this data science is going to bloom, right? So we are going to see step by step, starting from day one to the day end. We are going to see how we are going to implement all types of necessary things required in data science. Okay, so guys, automative analytics. We have seen automative analytics is the analytical capability. So in day one, I have shown you what is our benefits, what is our challenges, what are our applications, right? In day two, we are going to see change in data preparation, right? We're going to see that. So guys, as I said, if you want to follow this, always go to the browser and search data science mind map. Okay. So data science mind map by 360DigiTMG. So you can get various of mind maps, guys. So as I'm explaining domain, so when I open this data science mind map, so we have seen what is meant by CRISP-MLQ, right? So before going to this part of mind map, guys, I want you to get a recap of what we have done. Okay. So introduction we have seen. So this AI, artificial intelligence, and machine learning, and this all type of algorithms are tracker user-defined metrics, like a larger data sets where you're going to face desired business outcomes. What will be my business outcome when we're going to apply that, right? And it generates alerts of any notable changes at fixed intervals or triggers and delivers analyze. So guys, this automative analytics, which gets automatically detects, right? Which automatically detects anything, okay, without any human interference, as I said in the first day, right? That is what is automative analytics is. So what are the benefits we are going to get? What is our challenges? So what are our application and what is the conclusion, right? So the benefits of this data analytics, guys, in this domain is the automotive industry has led to smarter and efficient and more connected vehicles. Okay, basically how it's going to boost our sale, what type of marketing we're going to increase, are our marketing going to increase or it going to decrease. Okay, we are going to see how it's going to boost, okay, in our sales as well as marketing. And challenges, guys. So what will be the challenges I'm facing? So the challenges, we're going to see excess production related costs, right? So when we're going to see automative analytics, right? So whenever I say automative analytics, always do a research. You become a data analyst or data scientist. Your job is always doing a research. Okay, the self-driving evolution, sustainability, the shift of ownership to access. So these type of challenges we'll be facing when we're going to do this, apply the steps of this data science, guys. We'll be seeing the challenges which are very important to us. Okay, and after that we'll be seeing what is our applications. Okay, so what are the applications of this automative analytics? So the predictive maintenance, warranty analytics, driver and user behavior analysis, safety and security management, right? So when you're going to buy any car, let me say an example. So you'll always see the features. We'll always see what are the security we're getting, right? How many airbags we have, what type of stereotype, what type of gears, what type of wheels, right? We're going to see the complete thing. The same thing here, guys. What is our applications of automotive analytics? We're going to see predictive maintenance, warranty analytics, the traffic management, dealer performance. Same type. The applications of automotive analytics is are these guys. Okay, safety and security, driver and user behavior, dealer performance, and much more. Okay, and what was the conclusion we got to this? So in yesterday, I have said you some examples and I explained you what is the conclusion we're gonna get of this automotive analytics. Right? The modern automobile manufacturers are tracking their products and machinery using RFID. So what is RFID, guys? RFID is nothing but radio frequency identification. Basically tags, guys. Okay. The see how we're going to tax approximately what is my heart sensors. Okay, and from the above use cases, as I said, guys, the use cases which we are gonna explain you, right? It's gonna three. Okay, we are gonna see how we are gonna implement this automotive analytics in KN and K means how we are gonna implement KN in this automotive. So what is the result we're gonna get? How it will be useful for us? What can we learn from this? Right? So these things we'll be seeing. Okay, and good automotive analytics practice can go a long way in training, attaining sustainable competitive advantage. So if the product, if the automotive analytics practice can be attaining in good way, sustainable competitive, it will give us a good this one by like advantage, right? So guys, so moving on, we'll be seeing what are the things we need, okay, to apply. So guys, when we went to the next session, we have seen what is meant by crisp MLQ, right? Meant by crisp MLQ. So what is crisp MLQ, guys? It is nothing but cross-industry standard process for machine learning quality assurance, right? So guys, let us move on to the data science mind map. So I stress you to always go to the data science mind map, okay? Because you'll be getting the always the updated things, guys, which has been done, okay? So the data science mind map. So guys, in yesterday's session, we have seen what type of business understanding we need. So how to understand business object, what are business constraints. We have seen those things. Okay. So while jumping on, so we'll be seeing what is cross-industry standard process for machine learning quality assurance. So guys, when I said if you are more curious, always go to the blog. Okay, the blog which is done by the CEO himself. Okay, so you can always, okay, which is very important. And what is the business understanding? So I'm not gonna take much more time for you here. So I'll be going on to this day two talk, right? So I know you'll be waiting for that. So business understanding. So cross CRISP MLQ, this cross industry standard process for machine learning has some steps, guys. So we have some 6 steps for. So what are that? Record business objective, record business constraints, the success criteria, recommended use constraint using 2 or 3 words, always uses optimization words, minimize and maximize, right? So these type of things we'll be having. Okay. So guys, we know what is record business objective, the problem, what is a business constraint, how to solve that problem, what tricks we have to use, right? So moving on, guys, we'll be seeing data understanding. So the day two will be starting. The day two will be starting with the agenda of CRISP MLQ methodology. What is machine learning? And machine learning in automotive analytics. So how we are going to apply this machine learning in automotive analytics? Okay. So guys, what is machine learning? Okay. So before going to this agenda, guys, I want you to explain about, okay, let me explain you about CRISP MLQ methodology. So guys, we have seen this, but some things when I was explaining this testing and evaluation, right? And you are not aware of deployment, monitoring and maintenance, right? What is business understanding in data? Business understanding in data is nothing but the problem and what is the thing we have to do, right? So after that, data preparation. So today we are going to see data preparation. Okay. So I'm going to go step by step and make sure you guys understand everything. So what is this data preparation? After that, we're going to go for model building, guys. So before going to data preparation and all, I want you to knowledge. knowledge. Okay, so what is meant by this model building, right? So I know some will be curious, so we can't wait. So can you give us a definition? Sure. So what is model building? What is this data preparation? So, however, we are gonna explain about data preparation today. I'm gonna say what is by model building. What is the purpose of model building, right? So, basically, in simple words, if you want, guys, it brings their ideas to life. Have you heard about that word? Basically, the model building. Any architect builds something. It's like, let me say about a rock. So he's gonna crave that and he's gonna present us in some form, right? So what is meant by that? For that rock, he has given some sculpture, the shape of some god. So what is that? He has given the life to a rock. It's the same thing, guys. The model building also is same. Basically, we are gonna give the life what we are gonna apply. So after understanding everything, data and everything, after data preparation, I'm gonna give life. So I'm gonna build the model. Okay, I'm gonna build a model like same like a sculptures do, right? They're gonna take some rock and they're gonna crave and they're gonna after carving that, they're gonna give us the sculpture, the idol, right? So like we'll be thinking, okay, it's very good. Okay, he has given. So what they will architect will think he has given some life to a simple rock. The same thing here. After doing data preparation and everything, after this sculpture craves, right? After that, after the carvings, the same thing here, the data scientist is going to do the data preparation. After data preparation is going to do the model building. Okay, so what are the types of model building? Okay, so if you ask this question, there are three basic types. Okay? There are three basic types of this model buildings. Okay, so model building in this data science. So why we need this? So the model building is a process. It involves setting up ways of collecting data, guys. Okay. Basically, I can say understanding and paying attention to like what is important. So what is important in the data to answer and what questions you are asking. Finding a statistical, mathematical, or simulation model to gain understanding and make predictions. Okay. So what is this model building process? The basic steps of the model building process are model selection, model fitting, and model validation. Okay. So as we said, what is the purpose of model building? We have seen what are types of model buildings, right? We have seen different types of model building, guys. Okay. So moving on, what is this testing and evaluation? The terminology testing, guys. When I say testing, what is the thing you're gonna remember? Okay, testing. We're gonna test something, right? Testing and evaluation. So testing and evaluation, it is a process by which a system or components are compared against requirements and specification through testing. Okay, it's a process. So basically, I can say when a system, like what are the components are compared to against what are the requirements, right? The specification to testings. These type of things we'll be seeing in testing and evaluation. Okay, so the name itself says testing. What are these like testings, right? We're going to test our model. Okay, basically how we are gonna this, why this testing and evaluation is important, right? So if you can ask me that also. So this testing and evaluation is important, guys, because it provides a framework of knowledge. Okay, it provides a framework of knowledge and capabilities of selected to appropriate of particular level. Okay, framework is basically knowledge. You're gonna get some knowledge about capabilities selected to be appropriate to a particular level. Okay, this test evaluate not only on progress on achievement also, guys, it also do the effectiveness for teaching materials of methods used. Okay, so as I said, as we move on further, I'm going to explain you about in complete details about this testing and evaluation deployment. Okay, so deployment. What is this deployment? The name itself says deployment. So deployment, this model deployment is a process of putting machine learning models into a production. Okay, so this deployment is nothing but it is a process of putting machine learning models into production. Okay, this make the models predictions available to users, developers, or systems so they can make business decisions. Okay, based on data interaction or the application interaction and much more. Okay, so this deployment in this machine learning, guys, like let me say it is a I can say it is a process of placing a finished machine learning model, okay, into a live environment where it can be used in front of intended purposes. Okay. So deployment, it's a very important thing, guys. When you build a model, we should know always how to deploy a model. Okay. What is this monitoring and maintenance? Okay. After deploying the model, guys, you can't just leave the model, right? You should always maintain, you should always monitor that. So what is errors we are getting? So how to solve that? So are we maintaining our model? Okay. So that things you should always do. Okay. So as I said, we'll be going on deep as upcoming in the upcoming sessions. So we will move on. What is this machine learning, guys? Okay. So before going to the machine learning, so let me explain you about data preparation. Okay. So guys, let me say about data collection. Okay. So data, perfect. So we are going to see what is meant by data collection. Okay. So primary data source. So when I said data collection, so as I said, guys, still we are not into data preparation. Okay. As in the session, the yesterday's session, we have seen data types. So I want to make sure I'm not going to skip any topics and make sure you're going to learn everything. Okay. Primary data source and secondary data source. Okay. So let me read it out for you and give you the understanding in simple terminologies. Okay. Data collected at source. Examples are surveys, design of experiments, simulation, web scraping, social media extraction, IoT sensors. Okay. This IoT sensor also data can also be used as secondary data. So what is the secondary data and primary data? So guys, the data which you get completely is called as primary data source. So what is meant by that? So saying complete data in secondary data, we won't be get complete data, right? So let me explain you more deep. So primary data source, guys. So let me talk about any game. So if you buy any game licensed version, guys, right? The licensed version, you'll get the complete game. So you will not be missing anything, right? So the game developer has developed some game. So if you are gonna buy the license, means the CD. So let me talk about GTA. I hope everyone has played GTA in the chats, right? So sometimes when you download it from internet, sometimes you'll not get the complete data. You'll be getting like demo, the app will be crashing, the game will be crashing, some cheat codes may not work, right? So same thing. What is this primary and secondary data sources? So if we're gonna ask us a difference, this primary and secondary data source has some major difference. Okay, primary data source, the data which you get completely. In the sense, when I said GTA, guys, when you go and buy the license version, you don't have to worry about anything. What you'll get the complete game. There will be no game crashing. There will be no demo. There will be license key, right? It is valid game, right? So, sir, okay, primary data source I have said. So when I explain about secondary data sources, data collected beforehand, in the sense when I said when you download a game or anything, okay, you may not get the complete data. You will get like a demo game. I said like demo, the game may be crashing, right? But we have advantages and disadvantages in this both ways. So, sir, you're saying primary data source is good, and you're saying disadvantages also there. Yes. So the cost is high. Okay, see the costly and time consuming. Okay, so we're gonna buy the license version. Okay, it might cost some. It might cost, right? So if secondary data source, the disadvantage is we may not the complete data, but in chance if we get a complete data, is that time consuming for us, cost consuming for us, right? So we are going to decrease our cost. Depends on what data we are searching for also. Okay. For one particular data, if you don't get that, that is some issue. But when you buy the license version and everything, so these things you have to. Okay. So moving on, we'll be seeing the difference. Okay. So let me explain you about what the data science mind map says. Okay. Get data for extract variable of interest, costly and time consuming. See, as I explained about the game, same examples have been here. Okay. And the examples of this data collected beforehand, the secondary data sources, RDBMS, SQL databases, right? So you can download SQL, the sample things, and data is also easily available. If you go and search something on the Chrome, you'll get the data, right? And data may or not may be the variable of interest. So same things, guys. So what I explained, so I explained you it in more easier way. Okay. So moving on, we'll be seeing what is this data version control. Okay. So before going to data version control, guys. Okay. So as I said, we'll be going step by step. Okay. Data preparation is important to us. Is also important, but when I explain data preparation, you'll be able to understand what is important. Okay. So what is this data version control? It's a modification on the data set should be as documented, same like as a project chart, the documentations. Okay. So what is data description? The data should be described by their statistical properties, information about what format we're going to use, what inputs, what outputs, what units, right? Required about domain knowledge. The complete thing. So when I'm gonna do any project, this I should have a knowledge, I should do a research, and I should get a domain knowledge of that. Okay. So let me say I'm gonna work on AI chart. Okay. So I can't just go and say, okay, I'm gonna do AI chart, but I'm gonna collect data. No. You should always think in perspective of data science. Okay, they have given me a chatbot. So what are the models I'm gonna handle there? So how to collect data? What are the data I'm gonna clean? What are the techniques I'm gonna apply? Am I gonna use this N and I'm gonna use CNN and I'm gonna use hierarchical, different type of things. Depends on what you're gonna use. Okay. So like the same thing, the data description. You should have a domain knowledge about everything. Okay. What is this data requirements? So the requirements can be expected feature values, okay, the range for continuous features or list of discrete features. And the format of the data requirements have to be defined carefully to include all possible real world values. So guys, data requirements is nothing but a format of data, okay, which can be defined carefully in all possible real world values. What is in the sense that is described is nothing but, guys, the expected features, okay, a range what we're gonna get, and all possible real values. Okay. So data description is done. After that, we are gonna see what is data verification. The initial and added data have to be checked according to the requirements. The best practice is data exploration, the techniques to investigate, the sample distribution, right? So the initial, how we are going to add data and how we're going to check according to the data which we have given, what is the requirements met, right? We'll be seeing that when we're going to do this video. Okay. So guys, so today's the day 2. We are going to see about data preparation. Okay, guys. So let me write it down for you. So day 2, what I want to explain was data preparation. I have covered everything. Okay. This was also about day 2, the new topics which we have seen. Okay. So data preparation. So you can see, guys, data cleansing, data merging, data wrangling, data organizing. So what is mean by this? Right? All the same. So how we have. So what type of methods we are going to use, right? So we will be seeing all the things. Okay. Typecasting. So what is typecasting? Converting one type to another. Convert one type to another. Right? The question will be arising. So why we need to convert this typecasting? So guys, typecasting is nothing but we're gonna convert, compile mathematical changes one type to another, one depending what we want the program to do. Okay. So in the sense, let me say I have an integer value here. Okay. I want to make it as float. I want my data to be float. So typing one data type to another is nothing but typecasting. Okay. In simple terminologies. When you see example, see integer to float, arrays to series or data frame, it is a compiler. Okay, this typecasting, the compiler automatically changes one data type to another on depending on what we want the program to do. We want my program to integer to float or float to integer, depends on you. What you want to do, what the program want to do depends completely on you, right? You are the thing, you are the main, what you're going to work on, right? So, so guys, if you ask, so there are any types of typecasting? Yes. So we have different types of typecasting, guys. There are two types. Okay. So one is widening typecasting, and next is narrow typecasting. Okay. So we're not going to go deep into that because we're going to see what are the data preparation. So you have to understand only what is meant by typecasting and what types of we have. So typecasting is nothing but converting one data type to another data type. Okay, automatically I can say the basically we're saying what the program want to do. You're asking integer to float or float to integer, depends on. Okay, so what is the code for that? So you can see as type. Okay, and the close open the parenthesis. I hope it is clear. Typecasting, handling duplicates. So guys, the terminology, the word terminology, handling. So we are going to handle duplicates. So what is handling duplicates? Right? Getting single source of truth from various entities in one such example. So it might be a little tricky for you to understand. So let me crack it down for you guys. So let me say handling duplicates, right? So let me say there is one table. Okay. So I'm gonna say here have serial number, okay, names, and serial number 1 2 3 will be there, and name will be Vijay, Vijay, Vijay. Okay, and the second table also have the same thing. Serial number 1 2 3, Vijay, 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 name. One more table. Okay, same thing. Same thing we have. So do we need? So let me say I have one Excel sheet, big Excel sheet. Okay. Alright. So for the example, and have this 3 tables. So do I need this database, guys? Everything consists the same. So why to uh, enlarge my data, right? Why to make my data more spacious, right? So as I'm saying, table 1 is also same, table 2 is also same thing, table 3 is also same thing. Why do I need this? Can I remove this 2 and keep only one table? So getting single source of truth from various entities in one such example. The same answer is giving. Do I need both? No, right? So if I get one, is that enough? So that is in simple terms, I can explain what is meant by handling duplicates, guys. So if you're gonna ask me, sir, what is the code? Right? So guys, as I said, the data science mind map is designed in such a way that you can this data science mind map, okay, you'll get all the information, okay, you don't have to go to net and search everything. The terminologies, if you understand, that is fine, and you don't have to search the codes also. Okay, the code will be available. Okay, so when you see the code, so how to dot duplicates data dot duplicated, right? The codes you can see data dot duplicated, and next one is data dot drop duplicates. How to drop the duplicates. So we have this. Okay. So how do we handle this thing? This handling duplicates in data science, right? So I know the question will be arising. So how we are going to handle this duplicates in data science? So now you have known that there are duplicates in the data set, and you want to remove the duplicates, okay, like from other data sets. So there are two ways. So as I said, you have seen we have tables, right? So let me undo that. Okay. So as you have seen, we have 3 tables. And in 2 tables, we have seen there are duplicates in the data set, and you want to remove the duplicates on the data sheet. So how we will do that? There are 2 ways to remove that, guys. One is deleting the entire row, and other is removing the column of the most duplicates. Okay. So the codes, if you want, the codes are data dot duplicated, data dot drop duplicates. Okay. So guys, so We are saying how to remove duplicates. Can we avoid that? How can we reduce data duplication? Right. So guys, we have some steps, okay, to reduce the data duplication. Basically, what you have to do, yeah, however you're going to search on duplicates, identify the duplicates, right? Identify the duplicates data in your first data set only. And after that, remove the duplicates by finding them and merging them together. After that, use any app to recognize the dupes. Okay, like basically we have some apps. Okay, so you can remove like that. So guys, why like what is duplicate data in data science? Okay. So understanding duplicate data. Duplicate data is any record. Okay, that shares data with another record in database. The same thing. Okay. So guys, we have seen what is meant by handling duplicates. I assume that it's clear for you, the typecasting and everything. So guys, outlier analysis treatment. So what is this outlier analysis treatment? So guys, outlier analysis treatment, right? So this outlier analysis treatment, guys, let me say in simple words. So let me explain what is outlier analysis treatment. So if we don't have to get confused. So let me say there is some data. There is some data points. Okay. So there is some data points. All the data sets are near. Okay, let me change them. Okay. The data points, guys. All the data points are nearby. The one data point which is far from these things, okay, which is far, okay, which is far from here, okay, is called as outlier analysis treatment. Okay, the data points which is very far from other data points is called as outlier analysis treatment in simple terminology. Okay, so if you have to understand the concept, what is outlier analysis treatment, right? You don't have to go deep, guys. You can understand it by simple terminology too. Okay, outlier analysis treatment, right? So we have some different techniques also, guys. Okay, we have like 3R technique, masking, right? And we have swamping, linearization. Okay, so that is what is meant by outlier analysis treatments. So if you're going to ask me, sir, what are the techniques we have? We have 3R, masking, swamping, linearization, and so what is this 3R technique? Is nothing but, guys, retain, rectify, and retain. So 3R technique. So guys, rectify, retain, and retain. Okay, so what is meant by that? So as we have seen this, guys, as we have seen how to solve this with this outlier analysis. We have some techniques, 3R technique. We are going to rectify our data. We are going to retain what are the data we need, and we are going to remove the data. Okay, the terminologies may be differing, guys, but the answers are the same. Okay, so that is one thing. And if you ask for masking, so guys, outlier exists but fail to detect. So here, when I say, so when you see this, guys, okay, so let me change thing. Okay, okay. So when you see this outlier analysis treatment, guys, you can detect, okay, there is an outlier, sir. You can see. But what happens in masking? It will not able to detect outliers. Outlier exists, the outlier is existing, but this masking will not be able to detect that. Okay, that is called as false negative. Okay, that is called as false negativeness. Outlier exists but fail to detect. So why it is failing to detect? So guys, the masking is for that. Okay, masking. This masking technique. Okay, in this data science, guys, we have different type of analysis treatment, right? So why we need this masking? We have different type, right? This data masking, like I can say, we have different type of techniques also, okay, in this masking. Some are used for like identification, some are used for protecting sensitive data. Okay, depends on how we are gonna go. Okay, so guys, I'm not gonna go more detail in that. So I just wanted to show what type of outlier analysis treatment we have. So detecting non-outliers as outliers, the swamping. So in some condition, why we are getting this search? So outlier analysis treatment is in the sense we're going to remove outliers. Why we need of masking and swamping? So in some rare things, we may require to say some of the data to detect as non-outliers, detect as outliers. Okay. So swamping, what is it's gonna do? It's gonna detect outliers as non-outliers. Okay. This swamping, guys. Okay. This is swamping. It's gonna detect non-outliers as outliers. What is masking gonna do? Masking is gonna say, okay, there is no outliers. Outlier exists, but I'm not able to detect. What is swamping is going to do? It's going to say, okay, these are not the outliers. These are the outliers. Okay, the one which is far is not an outlier. These are the outliers, which is very far. Depends on. Okay, so that is also false positive. The false negative and false positive. It is detecting non-outliers as outliers. So it is false positive. That is false negative. Okay, Windsorization. So what is Windsorization? The technique which modifies the sample distribution of random variable by removing outliers. See guys, masking and sampling, what it was doing? It was saying, somewhere saying, okay, the data is far from here, that is called as this, and which is far nearer is called as one. So Windsorization, the technique which modifies sample distribution of random variables by removing outliers. Okay, by removing outliers. Yes, so by removing the outliers, it's gonna say the technique which modifies the sample distribution of random variables by removing outliers. Okay. Yes, and 90% of Windsorization means all data below 5th percentile is set to 5th percentile, and all data above 95th percentile is set to 95th percentile. So you don't have to get confused here. So when we say 5.5, we round it up for 6, right? The same thing here. Okay, so don't have to get more worried there, right? So what is the code? So what is the code for that? So when I click codes, guys, you can see what is the code we are going to use. From feature engine, outliers, import Windsorizer. Okay, and Windsorization. Okay, so you can see what are the codes we can use. Okay, guys. So moving on, will we see what are the different methods we have? Still one more we have is trimming, right? So what is trimming? If alpha is set as 5%, then lower and upper 5% values are trimmed or removed. So it's gonna trim the data. So here, guys, Windsorization is different. Okay. So what is Windsorization is gonna say? The technique which modifies sample distribution of random variables by removing outliers. It's gonna remove only the outliers. But here, trimming means it's gonna cut down the data. So what happens if we cut down the data? There will be loss of data. Depend, right? So this trimming and Windsorization is different tests, and we're going to use it in different scenarios. Okay. So I hope outlier analysis treatment is clear. So we're going to see zero and non-zero variance. Okay. The terminology is zero and non-zero variance. Okay. So guys, this means zero and non-zero variance. Okay. Usually we ignore the column with the same entries throughout, or if majority entries are same. So guys, so as I said, usually we are going to ignore the columns with the same entries throughout, majority entries are same. Okay. So guys, what is this thing? So when I explain the details, guys, so we have seen, right, the two tables which we have seen the same entries. It's gonna ignore the same things, guys, the duplicates, right? So all entries of column name country show the name as USA, right? So if we have the same name as USA in one column in all the columns, do we need that? Can't we just delete that column? Or it's gonna save our database, save our thing, right? The same thing, guys. This is zero and non-zero variable. What is missing values? So missing values, okay. So the terminology says missing value, guys. Okay. So let me explain you about this. Okay. So what type of methods we have, why we are going to implement that. Okay. So the terminology says missing values, the values which are missing, right? So guys, missing values, we are gonna replace with them, okay, using imputation method. Okay, using imputation method, we are gonna sort this missing values. Okay. So missing values, guys. So missing values occur when no data. Okay. So what is missing values, right? One second, guys. So missing values, missing data, missing values, or missing data occur when no data value is stored for the variables in an observation. Okay, when no value data is stored in the value of observation, we are gonna go for missing data. Okay, missing data are common case in the occurrence of significant effect of the conclusions where it can be drawn from the data. Okay, so what are the methods we have? Variance, MCAR, missing completely at random, missingness at random. Okay, we have different type of methods, guys. Okay, we're not going to go deep on that actually. So we're going to see what are the important concepts we require. Okay, so this for domain analytics. Okay, so missing value is done. We are going to go for discretization. So what is discretization? Converting continuous data to discrete data. What is discretization means, guys? It's going to convert continuous data to discrete data. So why it is converting? So guys, discretization is particularly used for certain things, as I said, right? So we're going to convert continuous data to discrete data. The thing. So what is this binarization, rounding, and binning, right? So binarization is nothing but converting continuous data into two categories. Okay, it's going to convert the continuous data into two categories. Okay, and rounding, the same thing is it's going to round off the nearest value. So in school we have studied this. If it is 5.6, it is 6. More than 5.5, it's same, right? And it is less than 5.5, it's going to become 9. The gradings, right? So when you got 78.9, they are going to call it as 79%, right? The same thing here is the round. And winning, we have fixed widthing and adaptive win. Okay. So this was all about discretization and dummy variable creation. So one of the important topics I can say, okay, in all the things, we can say all the topics are important, but we'll be having some little more important things. It's called as one-hot encoding. Okay. So what is this one-hot encoding? So it's gonna give the codes in digital circuits. Okay, I can say. So it can be like how to define it. Can be defined as essential process of converting categorical data variables to be provided to machine learning things. Okay, so guys, let me explain you about that. So one-hot encoding. So how to get this library? One-hot encoding, basically ones and zeros, guys. Okay, one not encoding means ones and zeros. So what is the library? So the library, guys, is nothing but pd.getDummies. Okay, so how to drop first true and everything we'll be seeing here. Okay, so what is the one more thing? From sklearn.preprocessing import one not encoder. Okay, so when you want to import this sklearn, you can use this. Okay, so from sklearn.preprocessing import one not encoder. So where to use this? So guys, as I said, you have to do some researches, so you should always know where we are going to use this, right? So what is that? So that is a library, yes, where you can run it in a Python. Okay, if you want a library to begin, right? We're going to use that. Okay. So guys, after that, we are gonna see what is label encoding. Okay. So what is label encoding? So label encoding is nothing but guys, it refers to converting the labels into numeric form. So as we can convert them into the machine readable form. Okay. Label encoding guys. How to import that? From sklearn.preprocessing, import label encoder. So label encoding refers to converting the labels into a numeric form. So as we are going to convert them into the machine readable form. Okay, this machine learning algorithms, guys. When I said we are going to discuss about machine learning, right? So you can, it is all related things only, guys. So what I'm saying about label encoding, so it refers to converting the labels into numeric form. So as we're going to convert them into machine readable form. Okay. Machine learning algorithms can decide in a better way how these labels must be operated. Is that important in pre-processing step? Okay. Is that important in supervised learning? Okay. So like that, guys. So the question will be arising. Sir, you are explaining about label encoding. So when to use this label encoding? Right? So guys, when to use this? Label encoder is used when, okay, the number of categories quite large. Okay, as one not encoding, it can lead to high memory of consumption 101010100010, right? So label encoder is used when the number of category is quite large as one not encoding. Okay, so can you give us the difference between one not encoding and label encoding? Sure. So one-hot encoding is the representation of categorical variables as binary vectors. Okay, we're gonna label. Okay, label encoding is converting labels. We're gonna use this one-hot encoding. We're gonna increase the dimensionality of the data set. We're gonna see the label encoding. It's not gonna affect the dimensionality of the data set. Okay, so guys, the difference are only this much. Okay, one-hot encoding is the representation of categorical variables as binary vectors, but label encoding is converting labels or words into numeric form. Using this one-hot encoding, we are going to increase the dimensionality of the data set. By using this label encoding, it doesn't affect the dimensionality of the data set. Okay, so that is the difference between one-hot encoding and label encoding. So the next thing we are going to see is dummy coding scheme. So what is this dummy coding scheme, right? So talking about some scheme, no. So this it is a simplest form, guys. Okay, the most common coding. Okay, this simple coding, the system is called as dummy coding. Okay, it is a way to make categorical variables into a series of different variables. Okay, that have different variables in the sense variables that can have a value of 0 or 1. So it is nothing but one-hot encoding, the same thing, right? So does dummy coding have to be 0 and 1? See guys, indeed a dummy variable can take values either 1 or 0. It can express either a binary variable, okay? For instance, so what is this 1 and 0? So if you're getting confused, guys. So I can say man, okay, man and woman, okay. So why to use this, right? You'll be getting confused. So man and woman. So I'm going to train my model. I'm going to say, whenever man is there, give me 1. Whenever woman is there, give me 0. Right? The same thing, the categorical only for binary. It can express either a binary variable. Okay. So 1 and 0, man and woman. It's going to decide, okay, which number to encode to be 1, which to be 0, are categorical variables. For instance, like level of education, basic level, college level, postgrad. Okay. So that is how it's going to decide this. Why we need this 1 and 0. For simple example, 1, 0, man and woman. Right? So dummy coding scheme is nothing but a way to make categorical variable into a series of variables which contain have value of 0 or 1 only. Okay. So why do you use these dummy code variables? So guys, dummy variables are useful because they enable us to use a single regression equation and represent multiple groups. Okay. So guys, dummy coding scheme is the affect coding scheme. Right? So what is this affect coding scheme? So we have seen dummy coding scheme. Next is affect coding scheme. So guys, this affect coding scheme is nothing but it allows you to assign different weights, various of levels of categorical variable. Okay. Unlike dummy coding, this affect coding allows you to assign different weights. Okay. So there we said 1 and 0s, like man and 0, 1 and 0. But this affect coding scheme allows you to assign different weights, the various levels of categorical variable. Okay. So we are gonna get, it is unlikely different both than dummy coding scheme. Okay. It's gonna allow different weights too. That is one thing we are gonna see in affect coding scheme. Okay. So guys, you can ask me, sir, why do we use this coding, right? So to apply a different simple. Okay. So next one we have is bin counting scheme. So what is bin counting scheme? In short, I can say this bin counting scheme, it's gonna convert a categorical variable into statistics about the value. Okay. It turns large parts of binary representation of categorical variable such as that produced by one-hot encoding into very small tiny part things. Okay. So this bin counting is going to convert a categorical variable to statistic about that value. Okay. So the next one we have is feature hashing scheme. Right. So the terminology says feature hashing scheme. Right. So why we use this? Are they different from all? Yes. So guys, this feature hashing scheme, okay, it is a machine learning, okay, feature hashing scheme in machine learning. It is also known as hashing trick, okay, like I can say a kernel trick, guys. Okay, if you remember a kernel, right? So in machine learning, the feature hashing is also known as the hashing trick. Okay, it is a fast and space efficient way of vectorizing features. Okay, turning arbitrary features into indices in a vector or matrix. Okay, guys, it is a fast and space efficient way of vectorizing features, turning arbitrary features into indices in a vector or matrix. Okay, how does this hashing work? So if you ask me, it works by applying a hash function to the features and using their hash values as indices directly. Okay, rather than looking the indices up in an associative array. Okay, so the trick is often attributed to I can say Weinberg. Okay, so it's same thing as we're going to apply it on hashing. Okay, so this was all about dummy variable creation. So the next one we have is transformation. The name says transformation, right? Transformation. So transformation is nothing but transform. So when I say transformation, okay, it's going to transform. Okay. So data transformation is the process of changing the format, structure, or values of data. Right? Changing guys. So if you want to remember transformation, always you can go for transformers, right? So if you have seen in the childhood, it's gonna be like car, and it's gonna go like some robot. Same thing. Data transformation, it is a process of changing format, structure, or values of the data. For data, so where to use this? For data analytics projects, data will be transformed at two stages of the data pipeline, right? So what are data transformation techniques? So guys, data transformation includes data cleaning techniques and data reduction technique. Okay, so let me write it down for you. So guys, so transformation, data transformation has different techniques. Okay, so it has what we said, data cleaning technique, right? And we have data reduction technique. And we have different data reduction technique. Okay, and we have different data, like different type of formation also we have. So data transformation is an essential data pre-processing technique. Okay, it's going to provide, this data mining is going to provide patterns that are easier to understand. Okay, so we have these two types, guys. One is data cleaning technique and data reduction technique. So we will be focusing on these two. Okay, so as I said, as we move on further, we'll be discussing about. Okay, so transformation, we're gonna use log, exponential, square root, reciprocal, Johnson box, Cox, and we're gonna check for normal distribution. Okay, so these many things we have is transformation. So standardization or normalization. So why we need this standardization or normalization? It's gonna make our data scale free and unitless. Okay, so what it's gonna do? It's gonna do the data scale free and unit free. Okay, so we will be having different type of standardization technique. Okay, minimizing, right? So after that, guys, we'll be seeing what type of data we have. Okay, so standardized scaling. What is standardized scaling? Okay, so what type of standardized scaling we have? We'll be having standard deviation. Okay, so guys, after that, what we have? So how to import that library, right? How we are going to import that? Okay, and what is the standard deviation? What is the mean? So mean is 0 and standard deviation is 1. Okay, so for the standardized scaling, min max scaling or range method. Okay, min max scaling or this method. So we are going to import them using sklearn pre-processing import min max scale. Okay, so what is this robust scaling? Okay, so as we are going to implement, guys, we'll be seeing this. Okay, string manipulation. So guys, we have different type of manipulations. Okay, so string manipulation, we have tokenization. What is tokenization? We're going to see stemming, lemmatization, stop word removal. Okay, word embeddings. Okay, what is tokenization? Converting sentences to words. Okay, converting sentences to words is called as tokenization. Okay, converting sentences to words. Okay, so breaking up of sentences. So what is meant by stemming or lemmatization? So guys, it's gonna reduce the infected words, okay, to their base form. So the stemming, it's gonna reduce the infected word to their base form. So I'm gonna say their base form. So what it's gonna say, right? Their base form. So guys, first talking about stemming. So I'm gonna point it as red and I'm gonna write it down right. This color on. Okay, so you'll understand it easily. Stemming, it's gonna reduce their base form. So what is meant by that? So let me say history, history, and histo, histoid. Okay. So what it's gonna do? Okay, the stemming, it's gonna reduce the infected word to their base form. It's gonna give it as history. Okay, it's gonna take what are the common things. Okay, it's gonna give it as history. Okay, it's not gonna give it in dictionary form. Okay, we know the word is history, right? This word is perfect. So what is lemmatization is gonna do, right? So lemmatization, guys, is nothing but it's gonna reduce the infected word to the dictionary form. Okay, it's gonna reduce the infected word to the dictionary form. Okay, it's gonna take it as it's gonna give history. In dictionary, we have this form. So it's gonna give us this form. Okay, guys. So this was about stemming and lemmatization. So stop word removal. We'll be seeing what is a bag of words and all. Okay, as we move on. So, guys, sting manipulation we have seen. So, as I suggest, if you want to learn more thing, you can always go to the blog. Okay. So, moving on, we'll be seeing exploratory data analysis. So, guys, there are four moments of business decision. Okay. There are four stages of analytics and four moments of business decision. Remember this, guys. Okay. We have four moments of business decision. So, what is first moment business decision? What is second moment business decision? What is third moment business decision? What is fourth moment business decision? Okay. So, guys, first moment business decision is called as measure of central tendency. Okay. Measure of central tendency. We have mean, median, and mode. Okay. So, what does this mean? It is also called as average. And you know, guys, mean, mode, median, mode, right? So, a different type of modes and all. Okay. Okay. So, first moment business decision is called as measure of central tendency. Second moment is called as measure of dispersion. Third moment is called as skewness. And fourth moment is called as kurtosis. Okay, guys. First moment business decision is called as measure of central tendency. Okay. And second moment is called as measure of dispersion. And the next thing we have is skewness and kurtosis. So, guys, I'm going to explain you about this. Okay. First moment we have seen it's have mean, mode, and median. So when I see measure of dispersion, guys, we have variance, standard deviation, and range. Okay. So the second moment business decision, we have these things. Okay. So variance. So what is this variance? Disadvantage is that its units get squared. Okay. And it's square root of variance we have. Okay. So range, maximum and minimum. Okay. These things we have as measure of dispersion. And skewness. So guys, as I said, we have four moments of business decisions. We have measure of central tendency, measure of dispersion, skewness, negative skewness or left skew. Okay. If the negative skewness is called as left skewed, and the positive skewness is called as right skewed. And when it is normal distributed, when skewness is equal to 0, then it is normal distributed. When skewness is equal to 0, then it is normal distributed. Okay. So we have different types. We have different type of things. When skewness is equal to 0, then it is normally distributed. So what happens in kurtosis? So here, when skewness is equal to 0, that's normal distributed. But in kurtosis, when kurtosis is equal to 3, then it is normal distributed. And in here, negative kurtosis is called as plateautic and positive is called as leptotic. Okay, these are the fourth moment business decision, guys. So you should always remember measure of central tendency, measure of dispersion, skewness, and kurtosis. Okay, so left kurtosis is called as is the negative is called as plateautic, positive is called as leptotic. Okay, So we'll be seeing what is the graphical representation. Okay, graphical representation we have univariate, bivariate, and multivariate. So univariate, okay, univariate, the terminology is univariate. Univariate means single, right? Right, as one, and bivariate means two, and multivariate means so. Okay, so univariate, guys, we have different type of plots for univariate. Okay, and bivariate also we have two, and multivariates we have three. Okay, so guys, so as I said, we have different type of graphs. So if you want to see examples, we have scatter plot for bivariate case. Okay, and multivariate we have Paris interaction. Okay, so next thing we are going to do is feature engineering. Okay, so next we're going to see is feature engineering. So what is this feature engineering? Okay, so guys, feature engineering we have on temporal data, numeric data, categorical text data, feature extraction, feature selection, right? Feature engineering on temporal data. It is data based on features. So where it is based on? It is based on time features, guys. Okay, this feature engineering on temporal data is based on these things. Okay, based on data features, and one more is based on data features. Okay, and we are going to see feature engineering on numerical data. Okay, feature engineering on numeric data. So raw measures, this binarization, rounding, interactions, binning, the statistical transformation, it's all gonna come under this feature engineering of numeric data. Okay, so raw measures, the binarization, the rounding, the interactions. Okay, so these type of things we'll be seeing this. Okay, and next what we have here is feature engineering on categorical data. Feature engineering on categorical data. So feature engineering on categorical data, we have transforming nominal features, transforming ordinal features, and encoding categorical features. Okay, we have these type of categorical data. Okay, so transforming nominal features are these things. Okay, so after that we'll be seeing the text data. Okay, how to encode that? Feature engineering on text data, the bag of words, how we are going to get bag of words of model, term frequency, inverse document frequency, guys, the TF-IDF. Okay, you don't have to get confused. The TF-IDF is called as term frequency, inverse document frequency, term frequency, inverse document frequency. Okay, and we'll be having the topic models, the word embeddings. Okay, so we'll be seeing the word embeddings, guys. Okay, it's like a full thing. Okay, we'll be seeing that. And feature engineering on image data. Okay, the image data. Okay, you can see different type of dimensions we have, guys. So I'm not going to go deep on that. As I said, we are going to see one of the important things which is required for domain analytics. Okay, I just wanted to show you how useful the mind map is. Okay, from 360, which we have developed, right? The mind map is so important, guys. Okay, believe me, if you go it through day every day once, it is done. Okay, you'll get almost 50% of your ideas. Okay, and feature extraction, feature selection is one of the most important things, guys, because we'll be seeing PCA and everything. Okay, feature extraction, we have automatic extraction, manual extractions, and PCA, this principal component analysis. Okay, we'll be explaining, guys. I'll be explaining you about this principal component analysis, why we are going to use this PCA, this automatic extraction. We'll be having ICA, different type of extraction we'll be seeing. Okay. And the next thing we'll be seeing is feature extraction. Okay. The feature extractions, we have filter methods, wrapper methods, embedded methods. Okay. So these type of things will be covering this. So as I said, feature extraction, feature selection, we'll be having all type of things. Okay. We'll be having feature extraction, why feature extraction is important, why feature selection is important, what are the filter methods, what are the wrapper methods, embedded methods, threshold methods, okay, the statistical methods, recursive feature elimination, okay. So how we are going to implement this in data science, right? You'll be getting curious. So how we are going to implement all these things. So guys, as we move on, as I said, we'll be seeing how we are going to implement these all things, okay. How we are going to implement this all things. So how we are going to implement this data preparation. So what type of things we are going to use, so what type of terminologies, what type of this methods using this K and K means how we're going to implement that, right? So guys, these type of things we'll be seeing as we proceed for the sessions. So guys, in day two, we have seen different data preparation. So I hope I had made clear what is meant by data cleansing, expert data analysis, feature engineering, why it is important in this domain analytics. Okay. So guys, in day three, okay, we'll be seeing how we are going to work on different, okay. So in the upcoming sessions, we'll be working how we are going to implement things, guys. How we are going to implement KNN, how we are going to implement K means, how we are going to implement this linear regression, machine, what we are going to see this, what is meant by machine learning, right? So guys, so when we go back to the slide, we are going to see what is machine learning, right? Machine learning is a branch of artificial intelligence and computer science, okay, that focuses the using the data and algorithms to imitate the way that humans learn, gradually improving its accuracy. Okay, machine learning is an important component of the growing field of data science. So as I said, guys, machine learning is so important in the field of component. We're going to use this machine, okay, this data science field. And through the use of the statistical methods, these algorithms are trained to make classification of predictions, uncovering key insights, data mining projects. Okay, this machine learning is booming, guys. It is very important in the field of data science. Okay, these insights subsequently drive decision making with applications business, ideally impacting the growth of metrics. Okay, so these are things which are very important, guys. In machine learning, we are going to use this. Okay, widely we are going to use this machine learning. Okay, so the importance of this machine learning, as we have said, machine learning in artificial intelligence and computer science, it is focusing on data, guys, of the algorithms which you're gonna imitate. Okay, so we're gonna imitate. So how we are going to imitate this machine learning? So guys, the day three we'll be seeing how what is meant by machine learning. So guys, so I know you'll be curious. So we have different type of machine learning, guys. Unsupervised machine learning and supervised machine learning. Okay. So tomorrow we'll be seeing these things, how we what is split method, what is this automative analytics, and what is the conclusion where we're going to get after applying this supervised learning, unsupervised learning, and this model evaluation into. Okay. So guys, so as I said, day two is done, the data preparation. So in day three, we'll be seeing how we'll be seeing what is the difference between this unsupervised and supervised learning. Okay. And we'll be seeing about the machine learning. Okay. So thank you for attending the session. So be sure you'll be available for tomorrow's session. Okay.